So this is number 4 from Free Response 2009, and what it says is in part A, it says find the area of R. R is the area which underneath the curve from 0 to 4. So what you're going to do is use an integral or antiderivative in order to find the area of R. So we already know that R is from 0 to 4. And what you're going to try to do is find the area underneath the curves, both curves, from this distance. So from 0 to 4, which is the top curve, is square root of x. So this one is your top curve, and you do the bigger curve minus the smaller, which is x divided by 2. So right here you have the integral from 0 to 4 of square root of x minus x over 2 dx. When you plug that into your calculator, you get 4 over 3, or 1.33333, and that goes on forever. So, part B says, find the region R is the base of a solid. For this solid, the cross-section perpendicular to the x-axis are squares. Find the volume of the solid. So, we know, what do we know? The area of a square, and it's kind of easier if you draw out the square, is s squared. It's the side, s standing for side. So, in order to find the volume, if we have given the area, you do the integral, or the antiderivative, s squared ds. In this case, s equals r, the region area underneath the curve. So, s equals square root of x minus x over 2. What you do in order to find the volume of s is you plug that in where s may be s squared ds. You plug in the area, or the area of r, or the actual meaning of s. So square root of x minus x over 2, in parentheses of course, squared between 0 and 4, because it's still between the same bounds. And when you plug that into your calculator, you get 8 over 15, or 0.533333. Part C says, write but do not evaluate an integral expression for the volume of the solid generated by R is rotated about the horizontal line of y equals 2. So let's look at the graph. Y equals 2, I kind of already have it up here, is right here. So you have to decide which one is furthest away from y equals 2. In this case, you have this curve right here, which is square root of x, which is smaller than this curve, x divided by 2. So in this case, you're not going to have the same order of your integral. Also, it's 2 minus the curve. So in this case, because it's being rotated, you have pi, the integral between 0 and 4, because it's still between 0 and 4, parentheses 2 minus the bigger curve, which is x over 2, parentheses, squared, because it's rotating around the x-axis, minus 2 minus, in parentheses again, square root of x squared dx. And they just asked you to write and not to evaluate, so that is your answer.